In today's tutorial we will try a retrosynthetic analysis of Valium, also known as Diazepam, a rather strong sedativum. This is the structure. So we have a benzene ring here, a 7-membered ring on that side annihilated with 2 nitrogens. And this parent structure is called a benzodiazepine. Well, how do we approach a retrosynthetic analysis? Looking for functional groups and especially strategic bonds, those which are easily formed. In our retrosynthetic analysis, we can break those bonds, getting to simpler structures. Well, where do we have strategic bonds? For instance, here between the nitrogen and the methyl group, since by alkylation of a nitrogen compound, this bond can be easily formed. So let's already draw as one ingredients a methyl group having a leaving group attached and therefore accepted reactivity. Then such amide bonds are also easily formed, and here we have an imine functionality which is also easily formed, in that case by a condensation process between a carbonyl compound and an amino group. So what partial structures do we have now if we cut all those bonds? Here we have an aniline with an acyl group in ortho position, and that part, well, there is certainly a glycine derivative. For instance, we could use a glycine ester. So, how could we approach this reaction? Well, just put those two together, condensation here, and since then the aniline functionality is intramolecular in close proximity to the ester group, heating it up, an amide formation, in this case a lactame cyclic amide formation, will take place. Of course, we could also go further back. If we don't want to apply an aniline derivative, we could also start with chloroacetic acid chloride and having in between somewhere ammonia as another reagent. So one can later on decide in which sequence we want to apply which reagent. And indeed, all variations have been done and were successful. However, we should have a look at these structures. Where do we get this from? So here the retrosynthetic analysis just goes on. Well, certainly we have here the strategic bond, and then we simply get to 2 starting materials, parachloroaniline and benzoyl chloride with the idea, well, we need a catalyst, and this is a Friedel-Crafts. Acylation. And we need a catalyst, and a good catalyst in this case would be zinc chloride. As the catalyst, while in Friedel-Crafts acylation you have generally had the catalyst in equimolar amounts. Well, but you might criticize this idea, since the aniline should also be capable for directly reacting with the benzoyl chloride, giving rise to this amide. And you are right, this should be indeed the case. But it is already known for maybe 80 years or so that the same Friedel-Crafts catalyst, zinc chloride, at elevated temperatures, at about 180 degrees, can catalyze this rearrangement from here to there, and this is one type of freeze rearrangement. Oh, okay, and therefore with this freeze rearrangement as an additional element, we have solved the problem of the retrosynthetic analysis of Valium. Thanks for listening.